Something unusual has shown up in the latest observations of Mars. When scientists began analyzing new data from the James Webb Space Telescope, they expected the same thing we've always seen: a dry, lifeless world covered in dust and rock. But that's not exactly what appeared. In certain regions, the data revealed formations that don't look entirely random. Shapes that seem almost organized. At certain angles, they resemble something disturbingly familiar, like a form you wouldn't expect to see on a planet that's supposed to be dead. At the same time, gases were appearing and disappearing faster than expected, and parts of the surface didn't behave like a completely inactive world. Individually, none of this confirms anything. But together, it points in a direction scientists have been trying to avoid. Because if Mars is truly lifeless, then none of this should be happening. So the question is no longer just what we found. It's, have we been wrong about Mars all along? Now this is exactly the kind of situation we explore here on Simulation Hypothesis. The moments where something doesn't quite add up, where the data doesn't behave the way it should. Because sometimes the universe doesn't give clear answers, it gives patterns, and it's up to us to figure out what they mean. If you haven't subscribed yet, go ahead and do that real quick so we can keep exploring these strange discoveries together. Now, Mars is not supposed to be a mystery anymore. We've sent orbiters, landers, and rovers there for decades. We've mapped its surface in detail. We've studied its atmosphere, its seasons, even its dust storms. At this point, Mars is one of the most explored places outside Earth. And the conclusion has been pretty consistent. Mars used to be alive. Not with animals or anything complex, but with water. Billions of years ago, Mars had rivers, lakes, maybe even oceans. We know this because we can still see the evidence. Dry river channels carved into the surface. Minerals that only form in the presence of water. Sedimentary layers that look exactly like the ones formed at the bottom of lakes here on Earth. At some point in its past, Mars looked very different. Warmer, wetter, potentially habitable. But then something happened. The planet lost its atmosphere. Without a thick atmosphere, Mars couldn't hold onto heat. Water began to evaporate or freeze. The surface slowly turned into the cold, dry desert we see today. And that's why, for a long time, scientists shifted their focus. Instead of asking if life exists on Mars now, they started asking if life existed in the past. Now here's where things start to get interesting again. Because even though Mars looks dead on the surface, scientists have never completely ruled out the possibility that something might still exist there. Not on the surface, but below it. Mars has a subsurface. And beneath that surface, conditions can be very different. There are regions where temperatures are slightly warmer, where ice exists, where liquid water might occasionally form under the right conditions. And if life ever started on Mars billions of years ago, it might not have disappeared completely. It might have moved downward, away from radiation, away from the harsh environment, into places we haven't been able to reach yet. Now remember those strange signals we mentioned earlier. The gases. Because this is one of the biggest reasons scientists are still paying attention to Mars. Over the past couple of decades, multiple missions have detected traces of methane in the Martian atmosphere. Methane is a simple gas. On Earth, it's often associated with biological processes. Microbes produce methane. Living systems release it. But methane can also be produced through geological processes. So finding methane on Mars doesn't automatically mean life. But here's the strange part. The methane doesn't stay constant. It appears, then disappears, then appears again. Almost like something is producing it and then stopping. That pattern is difficult to explain. Because if methane were coming from a single geological source, you would expect it to behave more consistently. But that's not what we're seeing. And that's one of the reasons why Mars never fully stopped being interesting. Now let's come back to those formations. The ones that look structured. Because Mars has a long history of playing tricks on us. There's something called pareidolia, the tendency for the human brain to see familiar patterns where none actually exist. The most famous example on Mars is the so-called face on Mars. Back in the 1970s, images from orbit seemed to show a giant face carved into the surface. People thought it might be artificial, something built, something intentional. But later, higher-resolution images revealed that it was just a natural rock formation. Light and shadow, nothing more. So scientists are always cautious when they see something that looks familiar. Because Mars has fooled us before. But this time, the situation feels a little different. Because it's not just about what something looks like. It's about how it behaves. The formations picked up in recent observations aren't just static shapes. They're located in regions where chemical activity is also being detected. That overlap matters. Because now we're not just talking about visual patterns. We're talking about patterns that exist alongside changing chemistry. And that combination is harder to ignore. Now, to understand why this is important, we need to look at how Mars behaves as a planet today. Mars is not completely inactive. It still has weather. Dust storms can grow large enough to cover the entire planet. Temperatures shift between day and night. Carbon dioxide freezes at the poles and then sublimates back into gas during warmer seasons. So Mars does have active processes, but they are limited. They don't typically produce rapid, localized chemical changes. And they definitely don't produce patterns that look organized. So when scientists see gases appearing and disappearing, localized chemical activity, and surface patterns that don't look entirely random, they start asking a different kind of question. Not what is this, but what process could cause all of this at the same time? And that's where things start to open up. Because there are only a few possibilities. One is that this is all geology. Unknown chemical reactions. Subsurface processes we don't fully understand. Mars still surprising us. That's the safe explanation. The expected one. But there's another possibility. And this is the one scientists approach very carefully. Because it changes everything. What if Mars is not completely dead? What if something is still active beneath the surface? Not animals, not anything complex, but something simple, microbial, something that interacts with its environment, something that could explain why gases appear and disappear, something that could influence chemistry in specific regions, something that might even leave patterns behind. Now we're not there yet. We don't have proof. But the reason scientists are paying attention is because the pieces are starting to line up in a way they haven't before. And when that happens in science, you don't ignore it. You investigate it. Because if even the simplest form of life still exists on Mars today, then it means something very important. Life doesn't just start. It survives, even in environments that seem completely hostile. Even on a planet that lost its atmosphere billions of years ago. Even on Mars. And that possibility is exactly why the newest observations matter so much. Because they're not just showing us what Mars looks like. They're forcing us to ask a question we thought we had already answered. What if Mars isn't as dead as we think? And what if we're only just beginning to notice it? Now here's where things start to get a little uncomfortable. Because once you seriously consider the idea that something might still be active on Mars, you have to ask a much bigger question. Where would it be? Because the surface of Mars is brutal. There's almost no atmosphere, which means there's no real protection from radiation coming from space and the sun. Over time, that radiation breaks apart organic molecules, destroys anything fragile. Anything exposed on the surface doesn't last long. That's why most scientists agree on one thing. If life still exists on Mars today, it's not on the surface. It's hiding, and the most likely place to look is underground. Mars isn't just a dry desert planet. Beneath that dusty surface, There are layers of rock, ice, and possibly even pockets of liquid water. In fact, in 2018, scientists using radar data from the Mars Express orbiter detected something very interesting near the planet's south pole, a region that looked like a subsurface lake. Not on the surface, buried beneath layers of ice. At first, many researchers were skeptical. Liquid water on Mars today sounds almost impossible. But over time, more data came in. And while the exact interpretation is still debated, one thing became clear. Mars is not as simple as we thought. There may be environments underground where conditions are stable enough for liquid water to exist. And if you have liquid water, you have the potential for life. Now think back to those methane signals. Because methane is fragile. On Mars, it doesn't last long. Sunlight and chemical reactions break it down quickly. So if methane is being detected, it must be coming from something that is still active right now. Something that is producing it. Recently. And that's what makes it so difficult to ignore. Because methane doesn't just sit there for millions of years. If we see it, it means something is happening today. Now there are two main explanations scientists consider. The first is geological. There are processes where rock and water interact under pressure and produce methane. No life required. This happens on Earth too. So it's possible Mars still has some internal chemical activity that releases methane in bursts. That's the safe explanation. The one that doesn't change everything. But the second explanation is the one that keeps coming back. Biology. On Earth, a huge percentage of methane in the atmosphere is produced by living organisms. Microbes, tiny life forms that survive in extreme environments. Some of them don't even need oxygen. They live underground. They feed on chemicals, and they release methane as a byproduct. So when scientists see methane behaving strangely on Mars, they can't completely rule that out. Now let's go back to those strange formations again. Because this is where things connect. Mars has always had unusual shapes. Wind can carve rock into bizarre forms. Erosion can create patterns that look familiar. We've seen that before. But what's different now is the timing. The formations that stand out aren't just random. They appear in regions where chemical activity is also being detected. That overlap matters. Because now we're not just looking at something that looks strange. We're looking at something that exists alongside active processes. And when shape and activity appear together, scientists pay attention. Now here's something that doesn't get talked about enough. Mars is not completely frozen in time. It still changes. There are seasonal flows, dark streaks that appear on slopes during warmer periods. For years, scientists thought those might be liquid water. Now they believe they're likely caused by dry sand flowing downhill. But the fact that we had to debate that at all tells you something important. Mars still surprises us. And the deeper we look, the more we realize how little we actually know. We've explored Mars for decades. We've sent rovers across its surface. We've drilled into its soil. We've flown helicopters through its atmosphere. And yet we've barely scratched the surface. Literally, because everything we've done so far has focused on the top layer of the planet. And if the real answers are underground, we haven't reached them yet. That's why future missions are starting to change direction. Instead of just driving across the surface, scientists want to go deeper. They want to drill, to sample, to analyze what's happening beneath the ground. Because that's where the real story of Mars might be hiding. There's also another possibility, and this one is even harder to test. What if life on Mars doesn't behave the way we expect? Everything we look for is based on Earth. Water, carbon, familiar chemistry. But what if life on Mars evolved differently? What if it adapted to extreme dryness, extreme radiation? What if it doesn't leave the kind of signals we're used to detecting? That would mean we could be looking right at it and not even recognize it. Now bring all of this together. You have methane that appears and disappears, possible subsurface water, chemical activity in specific regions, and formations that don't look entirely random. None of these things prove life, but they don't fit perfectly into the completely dead planet idea either. And that's the problem, because Mars was supposed to be simple, a world that had its moment billions of years ago, and then went silent. But what if it did? What if something survived? Something small, something hidden, something that never needed the surface at all. That's what makes these new observations so important, because they're not giving us clear answers. They're giving us contradictions. And in science, contradictions are where discoveries begin. We're not saying there's a creature walking across Mars. We're not saying we've found aliens. But we are saying this: Mars may not be as inactive as we thought. And if something is still happening there, then the story of Mars is not over. And that means the biggest discovery might not be in the past. It might still be waiting for us right now.